Okay. Uh, I welcome you all to this Google Class online class meet for the follow-up of the lectures which I have assigned given to you. Uh, I will be discussing first the overview of the topics which I have assigned to you, and then I will the open the session for you to discuss if you have any problems. So whenever you are joining, please mute your mics and also close the camera so that you have the comfortable connectivity of the internet and the session. Yasin, please mute your mic. Mic or camera बंद का और mic mute का please. If you can't, then I will mute it. Mic mute बोले शे. Mic
No, sir.
mute का camera बंद का. नशी गोले
Okay, sir.
खादा. Click का screen बांधे click का camera बांधे click का. The screen बांधे click का लाला mic बराश. कने ज़बा बंद कम ज़ा बंद हो रहा I will mute it. और बेतरा बताई चिका. It's okay if you want to keep the camera on, but better बताई चे screen के सब camera off भी. Okay, so uh, the today is the 13th of June. This is the follow of the second week the class lectures which I have assigned through the email to you. Uh, I have very disappointing response in the last week. No one appeared, but anyway, since it is start, so I ignore at that time that you might have the problems in the connectivity, or you may not have the all the procedures, the know-how about the procedures how to connect. So anyway, I hope that we will have now the regular class and the students will be joining with the maximum number. Okay, so first of all, I will go through that. In the last week, I have given the, let me share the screen first. Okay. So you will be able to see the screen. Let me join myself as well so that I can see that you get all the shared document. Okay. Okay. Now, I hope now my screen is shared. All right. So let me now come to the first this topic. Okay. So since I have logged in myself as a participant as well, so I can see on my mobile that you are able to see the presentation or the lecture note which I uploaded on the physics website as well, and in the form of video on the YouTube as well. We will discuss question answer at the end, or in the meanwhile, in the middle you can ask question. The procedure is that you just put in the comment box, in the chat box, that you want to ask some question. So over there I will stop and I will give you the opportunity. Okay, so it's good. Now 13 people have joined. I will show you the grid view. Let us see first the grid view. That who are, this is the grid view. You can see the students who have joined at the moment. Welcome, Ziaullah. You were also absent in the last class. Anyway, now happy to see that now the considerable number is now joining the class.
Sir, some
Oh,
problem in the network.
erano tata single problem de todo electronics boy ve todo electronics master है पकारो चिता तो इस प्रॉब्लम नवे
सर हो बस एक प्रॉब्लेम हो दी वजह सर मैं क्लास
हाँ
अटेंड
हाँ
नहीं कर सॉरी सर.
ना लास्ट वीक प्रॉब्लम को दी वीक क्यों सम प्रॉब्लम्स था
No sir दी वीक की खुश निष्ठा माँ बस क्लियर करा मसला.
हाँ हाँ बस आप मसले क्लियर करवाए करना ठीक शो
जी
हाँ
सर जी
मसले
सर
हल्का
बिल्कुल.
हाँ हल्का हुआ
जी
हाँ
सर जी
हाँ
सर
ठीक
जी.
शो और सो माइक म्यूट का खप आराम किया ना और चिक से प्रॉब्लम भी क्वेश्चंस यू कैन पुट question in the chat box put that I want to ask a question so I will allow those students so that we have organized this session. Okay, so let me now share. This was the first lecture. If you remember, lastly we left where we left. We left the class before 12 March. The was the feedback schemes. Okay, so feedback was the last topic, and the next topic was the oscillators. So there's a good thing come out in the online classes is that I can now add you will see the beautiful animation which we may not have at that time in the class, but you will see various animations and the good pictures are the illustration or description of the devices or the construction of the devices as well in these video lectures or the PDF lectures. So the last week I assigned these two topics. Uh, Let me see. This is the oscillator. This is the basic working principle of oscillator. The second, this is called the number. I have tagged all the lectures. ELEC means electronics. OSC means oscillator dash S1A. So S1 means the section one, the part one of the oscillator section. Okay, oscillator section one. And further in S1, the part A and S1A, S1B, S1C, if there are multiple parts. So I have tagged those as the S in the section S number, whatever number is designated over here. So this was the last week I have assigned. The this week I have assigned further two more topics I will show you. So this is the S1A. The second one is I am now showing you. This one is the second one. It is the ELEC-OSC-S1B. Okay, this is the LC oscillator basics, but the circuitry will be discussed in this topic. So this is a complete class is dedicated to the oscillator section. So in the meanwhile, let me see the chats. Okay, आवाज सही नहीं आ रही सलाउद्दीन. Okay, the Ziaullah, Ziaullah, turn on your mic and let
जी
me.
सर
आवाज क्लियर दे जमा.
जी सर बिल्कुल क्लियर दी.
हाँ था तक क्लियर दे दा.
सर दा
You
सलाहुद्दीन सर दा बदल नेटवर्क मसला हुई.
de Salahuddin comes again. Salahuddin, from where you are, comes in at the connect way. Chat क्यों लिखा?
सर जी शफका नियर मोहम्मद एजेंसी.
हाँ हाँ बस खैर दे साफ आवाज दे क्लियर दे सफा सुथरा दे और सिंग ऐसा प्रॉब्लम दे इसे किस्म आवाज स्लो दे इस या इको दे.
सर जी इको के मसला राजी कला फुल राशि कला तत के
हाँ हाँ
राजी.
बस आगा नेटवर्क इशू दे दा खैर दे दा टोल वीडियो लेक्चर से मुं खबर है को लगिया यू दा बटोल रिकॉर्डेड भी और नेक्स्ट मीटिंग ते जब जता सोता इनवाइट को आगे के दादा दी वीडियो लेक्चर रिकॉर्डिंग बता सोता हूं मिलाओशी. So no problem with that. Come खबर है discuss को you can later on see that. In the meanwhile the text के साथ से question ही तो text box के chat के तो माता question को ले शे और सदस्य भी खबर अभी का ना I can discuss that. So आवाज clear दे हो but anyway
ओके सर.
दा वो issue दे खैर दे this are also मसला वर्सरा बलग अगर को manage को बा. You know mic lag mute का please. Thank you. You know that actually this is very the unforeseen the event came out that the this virus pandemic due to this pandemic we have this big break. So there's no way out. There's no way other way how to save your time. Okay, so the HEC and university has very wisely instructed all the faculty members to prepare ourselves so for the online classes. So we would like to have that the your time is saved, and at least the that remaining topics could be discussed, and you can study at home. We I have prepared my video lectures and uploaded to the YouTube. The links I have shared with you on my Facebook, and also in the emails. The if you don't have the links, then you can write in my chat box. I will provide you. You can see, visit my Facebook page again. Okay, so let me now continue. So these are the two topics which I have. The first is the oscillator, and I will just go through quickly, and I will take your feedback. Okay, I'm not going to teach in this class that the what the topic is about, and the classroom. This class is not for the classroom teaching. This class is for the follow up. What are the issues you have got? I have uploaded the complete lectures. Go and sit, relax, have these lectures, watch those lectures, and the study each and every part of that topic, and then note down your issues if you have got. I will just go quickly through those topics, and I will take your feedback if you have any problem. I suppose that today is actually supposed to be the next the second week lecture I was supposed to discuss over here, but since you have last week not joined, so I will go through quickly. Okay, this is the first topic, which is oscillator. And oscillator, it is the continuity of the feedback scheme. If you remember the last topic which we left, what is oscillator? Oscillator is an electronic circuit which converts DC electrical energy to AC electrical energy. Prime example, you can see the oscillator. This is the technical name of oscillator. The device, the UPS you have got at your home, which is converting the 220 the 12 volt DC into 220 volt AC. So the basic working mechanism, which is the tune or tank type, LC tank, C and L or LC tank type, the circuitry that is there. So this oscillator, you can see this AC complete cycle is generated. This whole description, the illustration I have explained in this diagram or in this slide, that once the DC voltage is fed in, what we have an inductor and a capacitor connected in parallel. Now these are the, you can see 8 stages. 1, 2, 3, the same one circuit. It is actually one circuit, but it goes through these 8 stages to build this whole complete one cycle. As you can see, A, B, C, D, E, F, G, H, then back to A. So the 8s I have. This is a beautiful illustration given in the Essentials of Communication Electronics, Slursberg, the book. But anyway, you can see that here we have. So these are the various stages. You can see in the figure A what we have. I will discuss this topic a little bit so that we can have idea about it. This is the point A, which is 0 volt. Okay, this is the induced, VI means induced voltage, which is picked up across the inductor L. So in the initially when DC is released, what happened that the capacitor is charged to the peak value. During the charging, obviously, because the low conductance is offered by the capacitor, no current is possible to flow in the inductor because of the low reactance here, and this reactance is higher. So over here, the capacitor is charged to the peak value. But once it is charged, now it offers then infinite resistance. As you know, the capacitor is a blocking device for the DC. So what happened there? This is the initial point. During the charging, as long as the capacitor is charging, the output is here is 0. So A is a point where we have VI, or the induced voltage, is equal to VA, which is 0 volt. Okay, so once it is completely charged, now it offers infinite resistance. Then the capacitor starts discharging. Now this reactance is less than this one. So the capacitor discharges through the inductor. The current start passing through the inductor. Now this inductor, you see the discharge is now is non-linear. One thing, okay, because the capacitor discharge is exponential. So it is non-linear, means the variable current is passing through. Initially the DC voltage comes, and this DC voltage also the charges the capacitor exponentially. But at the output, when it is discharging, the the current which is flowing through the inductor is non-linear, means the variable current when passed through the inductor. So what happens that the variable magnetic flux, this is called the expanding magnetic field. Okay, so this is the expanding magnetic field also, and the capacitor gets partially discharged. This expanding magnetic field produces an induced EMF, which is recorded over here as a from A to B. So this is a VB, okay? V induced voltage is VB. So you start getting the AC voltage at the output. Now the frequency of the output is fixed with the L and C value, which is, you are familiar with the resonant frequency, which is FR is equal to 1 over 2 pi under root LC. So L and C value determines how much this frequency should be. So in our UPS case, what we have, the frequency we need 220 volt. Okay, so this coil is made a bigger step up transformer so that it can generate up to 220 volt. Then the frequency is of 50 hertz. So LC should be of those particular values, so that the total, the resonant frequency formula will give you 50 hertz. So but in case of, you see, in the laboratory you have used the oscillators which you have got of the low voltage, which is 15 volt around. In that case also the DC is converted into AC, but over there what we do, we use the variable capacitor or the variable inductor. Rather, the dial you have got the variable capacitor on the front of the frequency generator. That variable capacitor makes the variable resonant frequencies at the output, so you can get up to megahertz frequency as well. If you change the L and C values, you can change the resonant frequency. Okay, here we are discussing actually the conversion of the DC into AC. So you reach over here point B. Now in this third stage, you can see the capacitor is completely discharged. So that means the magnetic field is expanded maximum. Okay, so maximum magnetic field means the peak magnetic field will produce here the peak. Over there we have induced EMF or the induced voltage over here. So this is the peak voltage, the constant voltage being taken, VI is equal to VC at that particular instant. Okay, then after this point C, we have the figure D. Now the voltage, the current, the field, the capacitor is empty completely. Now this magnetic field starts collapsing, breakdown. ये magnetic field कम होना शुरू हो जाती है, right? Collapsing means decreasing. But whether the field is expanding or collapsing, in each case the induced current is, in this case induced voltage produced. Now in this case, since now the magnetic field energy is stored, is collapsing, now induced current is being produced, but now in the opposite direction to the initial. इस initial direction से ये अब opposite हो गया. So it will start charging the capacitor again, but in the opposite direction, negative. This one initially it was positive. Okay, now it is the charging the capacitor in the negative direction. So that is designated by the point D here. It is coming down, the field is induced EMF is decreasing here we get, but in the meanwhile it is also charging the capacitor in the opposite direction. In the next stage, what we have, the magnetic field is completely collapsed. In this case it is completely collapsed, so VE, figure E is there. So, but capacitor is charged now maximum. So output is equal to V induced EMF at here is VE, which is you can see is 0. So let's see here on the graph as well. The VE is now 0. This E point is VE is now 0. So the next stage, again the capacitor will discharge. Capacitor will start the expanding magnetic field, but now in the opposite direction. You can see now the direction of these the lines of force. The magnetic flux is upward. In this case, this is a downward. So this is now opposite in the opposite direction. So means the induced voltage is also in the opposite in the negative direction. So that is the now point F, VF, which is now is the expanding magnetic field, which is causing induced EMF, but induced voltage, which is now in the opposite to the previous stage. So that is the case here. Then it is in the next stage again the field, the total capacitor is discharged on the whole the through the inductor, and the maximum magnetic field we achieve, and that case is there. You can see the at the point G. This is the maximum, but in the negative cycle, what we opposite magnetic field due to the opposite magnetic field. So over here we have the point G, the capacitor is discharged. So, but the peak voltage we get at the output. Then again in the last stage, what we have, you can see here, it start again collapsing, mean decreasing. Now this decreasing again, it brings the charging to the same initial stage, which we have in this case is the positive. So the from the source DC again joins it, and it starts charging the capacitor at the output and reaches to the to the point F, H, from H to GH to A, again back A. So here is the back from point H to A. So this is the initial point. The full complete one AC cycle is obtained from the DC, 12 volt DC. Okay, so one thing you should remember, I have this shown this figure. This is the damp harmonic oscillator output, means the damping mean the medium is resistive. So it is again the law of conservation of energy, that if you give it 12 volt and DC, and it will oscillate forever and producing this sustained without any decrease in the energy cycle. Actually this doesn't happen. What happens inside, actually this cycle completely decays very quickly, okay, because of the resistance of the wire, the inductor and the capacitor. So it is not possible to few cycles, 2, 3 or 4 or even 5, 10 cycles are produced, and then they decay quickly. So this damping takes place. Here the role of the feedback came into effect. That feedback, we have to now provide this signal, which is the AC signal, a feedback signal, so that it can sustain its oscillation in this proper the shape, so the distortion in the signal is not observed. So this is the basic working mechanism or the procedure or the technique which is used inside the LC, the tank circuit is called the LC tank circuit oscillator, LC tank oscillator circuit, popularly known as oscillator. We also call it as an inverter, or different other names are frequency generator. Various names are given, but technically it is oscillator section. Now let me show you the animations. If I have got, let me see. This is the to go to S1A. Okay, here you see, you go. This is a beautiful animation I have incorporated in the video as well. So you watch this animations. Now this is the tank, LC tank circuit. This is C and this is L. Now capacitor in this case is the negatively charged, and this is the polarity is other than I have shown the positive. Here it is negative polarity. Capacitor is charged and it will discharge. First it will discharge. Initially there is no voltage. Once it will start discharging, you will see the voltage, the magnetic field will appear over here. Here you can see when the after complete charging, discharge takes place and the expanding magnetic field is produced over here in the red file. So when it's reached the peak here, okay, I will show this animation will show at the end as well, the complete cycle as well. But let's concentrate on the how this field expanding field is being produced. Now collapsing takes place. Now the direction is reversed. You can see here, field start collapsing. The capacitor is now being charged in the opposite direction with the positive here. Initially it was negative, now it is positive. It doesn't make any difference if you take the whichever polarity. So here completely magnetic field is collapsed. Now once it is completely collapsed, now it's again completely charged and it will again discharge now with the opposite direction of the magnetic field, which is the green. In this case, it is showing the green. This is the negative part of the AC cycle. Red was the positive part, and this is the green is the negative part of the AC cycle. It is, remember, output is taken across this, the inductor L. So it is completely again charged, the expanded, and then again it starts collapsing, but again now comes back to the initial position, charging the capacitor in the initial stage, first stage position of the LC tank circuit. And that's how this whole process goes on. In case of our 50 hertz, if it's a UPS or inverter, the cycles carries on charging and discharging. So it is the LC tank basic working principle is exchange of energy, oscillation of energy between C and L. You see, the C and L, the energy is being oscillating back and forth between the capacitor and inductor. Right? You can see this is a beautiful animation giving you the concept of the oscillator. So let's see now how the AC cycle is generated. Here you see you'll be having the moment will show that here. So in this case, let's say, okay, this is a positive cycle. It is being represented in this case, expanding positive cycle at the output maximum and then collapsing, going down across the inductor. Positive cycle still you are getting. And then capacitor is charged completely in the opposite direction. Now it will discharge again, but this time in the opposite direction the magnetic field will be produced. And induced field, you can see the red is the negative one and the green is the positive in this case. So that's how the complete one AC cycle is formed. Still is the DC energy is being fed into this LC tank circuit. So complete cycle is there. So you see that's how this still is a slow motion. You can see this where the 50 hertz frequency means 50 times this in 1 second. This process takes place for 50 hertz. But in 1 megahertz oscillator, you can okay. This is the actual cycle we expect. We should have the AC cycle, but actually, what happens that due to the damping, we have this damp oscillations over there. The cycle decays with because of the resistive medium, the medium resistance. So that's over the whole. If you see the cycle, the oscillations are produced. AC cycle is being produced due to the exchange of the energy between capacitor and inductor. These are the credits. You can go and see over there. I have just made some modifications. All American 5 radio as well on the YouTube. You can see those videos over there. Okay, so that's the end of the first topic. Now let me.
Excuse me, sir.
I'm coming. I am coming. I am coming. I am coming. Okay,
जी सर, जी सर,
right. Zia, you want to say something?
जी सर।
Okay, go ahead. Go ahead.
सर, ये कैपेसिटर जब चार्ज या डिस्चार्ज होता है ये तो ये एक्सपोनेंशियली होता है।
जी जी
और यहाँ पर जो वेव शेप है
जी
एलसी
जी
सर्किट का, तो ये
जी जी।
जो प्योर साइन वेव शेप है।
देखिए, व्हाट हैपन्स दैट कैपेसिटर आपका चार्ज हुआ या डिस्चार्ज हुआ,
जी
हमारा
सर,
जो मकसद है यहाँ पे इंडक्टर में, अगर सपोज इधर मैं इसको हटा दूं, ठीक है ना, कैपेसिटर को हटा देता हूँ, यहाँ बैटरी लगा देता हूँ, ठीक है। बैटरी हैज लेट्स से ये 12 वोल्ट है, जो एक्सपोनेंशियली 12 वोल्ट की चार्जिंग और डीसी, अगर यहाँ बैटरी लगी होती सिंपल बैटरी, तो ये क्या
जी सर,
होता, कॉइल डायरेक्टली एनर्जाइज हो गए 12 वोल्ट के ऊपर, इसके ऊपर कांस्टेंट मैग्नेटिक फील्ड फ्लक्स जो है वो खड़ा हो जाता है, स्टैटिक फ्लक्स,
जी
which
सर,
will not be able to produce induced EMF, ठीक है ना। So
जी सर,
battery, direct DC battery will not work to generate an AC cycle. So what we smart thing the scientists have think of that the capacitor has the capability to charge exponentially and discharge exponentially. The
जी
job
सर,
of the capacitor is to provide this current. The exponential discharge means variable current. So variable current is fed to the coil. The current is no longer now constant from 0 to 12 volt, you can say 0 to 500 milliampere. It will be 2 milliampere, 4 milliampere. If it is expanding, increasing. So, okay, the current, if it is increasing, then from 0 to let's say 500 milliampere.
जी
So
सर,
it will provide the variable current. The job of the capacitor is to provide a variable current to the coil, right? So that
जी सर,
is not the case that you will get the graph of the capacitor. We are taking the output here along the inductor. The inductor, although it is a parallel capacitor, the current at the moment the capacitor is being discharged, and that voltage is now causing to drive this circuit through this current, which is now variable current. So the
जी
variable
सर,
current, which is the exponential now. Exponential means the variable current is now driving this coil. So variable current, due to this variable current, this variable magnetic field is observed. So this variable, you can see here the induced voltage, because now because the variable voltage will, this whatever there is a, that whenever changing flux is linked with the coil, it produce induced EMF. So that induced EMF is picked up across the coil, right?
जी
So it
सर,
is not that we are plotting the graph of the capacitor. Since it's a LC tank circuit, when LC capacitor is completely charged, so over there, what we get, the induced EMF voltage over here is equal to zero. We are picking up the induced EMF. We're talking about induced EMF voltage. But
जी
once
सर,
it is start discharging, that causes the current to vary. This is the main purpose of the capacitor. Variable current is over there.
जी सर,
Is that clear?
जी सर, ओके, क्लियर, थैंक यू सर।
Any other question? Okay, let me
नो सर,
see. Okay, in the chat box. Okay, good. Okay, anyone else have any question about this? You can join.
Sir, I have a
जी
question.
जी 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 जी.
Why we call it tank circuit? Yeah, tank oscillator.
Tank is, yes, it's a tank. If you see the here, it is the shape of this parallel circuit is a tank like, tank जैसे जा रहा है, ठीक है ना. Tank is the या ripple tank या आर्मी का tank कह सकते हैं, या water tank कह सकते हैं, ठीक है ना. So it's the diagram which else इसका जो ये है, जो shape है, ये से block diagram है, इसलिए इसको हम tank circuit कहते हैं. Otherwise there is no other logical meaning to it. Tank इसके साथ tank इसलिए भी storage, for the storage, right? Tank एक अगर आप logically concept करें तो tank is used to store वाटर रिजर्वायर या कोई चीज़ों को स्टोर करने के इस्तेमाल करते हैं। तो इस लिहाज से भी आप इसको एक दे सकते हैं, सिंबॉलिक मीनिंग, दैट टैंक मीन्स it stores energy, electrical energy. It basically converts, but the energy is being exchanged between the two components L and C, though. So it is causing the energy to back and forth flow, but it's still retaining that energy inside. So that's why it is called tank. Tank means the storage tank, right?
Yes, sir. Thank you,
ठीक
sir.
है?
Yes, sir.
Okay. Anyone else? Let me see the. मैं यहाँ देखता हूँ कुछ चैट में. Okay. Okay, now let me know, मुझे बताएं कि how many of you have the seen these topics, video lectures किस किसने देखा है? चैट बॉक्स में लिखें yes or no, ठीक है ना? चैट बॉक्स में लिखें, क्योंकि ऑडियो में पॉसिबल नहीं होगा, बट एनीवे चैट बॉक्स में आप लिखें. You take the attendance as well. Okay, Hafsa Rahman say yes. Okay, good. Anyone else? Okay, let's now we can have audio talk one by one. Abbas, we start from the very beginning. Ji, Abbas, unmute your mic. Can you hear me? Okay. Ji, Abbas.
Yes, sir.
जी. Have you studied those topics, seen those topics जो मैंने assign किए हैं आपको?
No, sir.
So start reading or studying those topics. मेरे क्योंकि PDF फॉर्मेट में भी है और उसमें भी फॉर्मेट में है, दोनों फॉर्मेट में है. तो आप उसको स्टडी करें और ये क्लासरूम डिस्कशन के लिए आ जाएं, और यहाँ पे जो भी आपके इश्यूज होंगे लाइव क्लास में हम एक दूसरे के साथ डिस्कस कर सकेंगे. राइट? ओके. एनीवन एल्स? Any problem to the students regarding the literature or the material I have uploaded? Access करने का कोई issue है किसी को? Since you are all on the online, we are on the net. एक request होगी, one request that please help your class fellows, students जिनके पास अगर कोई ये facility, accessibility आपका near by है और आपके पास इंटरनेट है, आपके पास कंप्यूटर है, लैपटॉप है या मोबाइल फोन है, तो ज्वाइन क्लास में भी आप 2-3 स्टूडेंट्स बैठ के वो ज्वाइन कर सकते हैं. इट्स नॉट दैट लाइक इंडिपेंडेंटली हर एक ने किसी ने ज्वाइन करना है. तो वहाँ पे सिर्फ मुझे वहाँ पे इन्फॉर्म कर दें कि भाई हम ये 2 या 3 स्टूडेंट्स हम इकट्ठे क्लास ले रहे हैं. तो इसमें हेल्प करें, अपने जितने भी फ्रेंड्स हैं उनको इन्फॉर्म किया करें कि आज के दिन क्लास है. दिस विल बी आवर रेगुलर क्लास इंशाल्लाह ऑन द सैटरडे, अनलेस अंटिल देयर इज एनी अनफोर्सीन, कोई अगर ऐसा काम आ जाता है तो चेंज होगी, तो आई विल इंटीमेट यू 1 वीक बिफोर, एक हफ्ता पहले आपको फ्यू डेज बिफोर मैं आपको इन्फॉर्म करूंगा. सो ये रेगुलरली मेरे गूगल कैलेंडर में एडेड है और हर हफ्ते आपको इसी में शेड्यूल मिला करेगा क्लासेस का. तो आप वो जो वीडियो लेक्चर्स हैं, आपके पहले 4 लेक्चर्स हो गए हैं, 2 इस पिछले, बल्कि हाँ 4 लेक्चर्स हो चुके हैं, तो आप वो दोबारा देखें. नेक्स्ट वीक के लिए मैं फर्दर 2 मोर लेक्चर्स रिकमेंड करूंगा. तो आपने करना है, 2 मंथ्स हमें टाइम दिया गया है आपका, जून और जुलाई, फिर अगस्त का आपको प्रेप लीज होंगे और फिर सितंबर में आपके खैर से एग्जाम का भी पॉलिसी आ गई है. देखते हैं ऑनलाइन होता है या, लेकिन मेरा ख्याल है कि इंशाल्लाह सितंबर तक SOPs के अंडर एग्जाम शायद आपको हॉस्टल, मेन चीज़ हॉस्टल में SOPs के अंदर लिविंग और रहना और ये सारे स्टूडेंट्स, उनके लिए हमारी मेन इश्यूज है और ट्रांसपोर्टेशन का. तो सितंबर तक होपफुली वो हो जाए. लेकिन पहले आपके प्राइमरी टास्क हमारा ये है कि वी हैव टू डिलीवर दी ऑनलाइन द लेक्चर रिमेनिंग कोर्स वर्क टू द स्टूडेंट्स. तो कोशिश करें प्लीज़ कि जितने भी आपके फ्रेंड्स हैं वो आपके साथ शामिल हो सकें. ओके, किसी और को अगर कोई क्वेश्चन है इसमें तो काइंडली बता दें, सो दैट आई कैन मूव टू द नेक्स्ट. ये पिछले वीक के टॉपिक हम डिस्कस कर रहे हैं. विल गो क्विकली. ओके, Now this is the next, I move to the next topic, which is the ELEC OSC S1B. This is oscillator section, obviously. This is the feedback, uh, the oscillator scheme, if you remember, but this is the title, so we will move on. LC, so we go through those, these same documents I have uploaded on my the physics website. You can online in the bar, if you click on the bar online teaching material, you will go to the directly to that page. Over there you can find the YouTube link as well, which is called cloud link, and the all those topics are uploaded over there. You can download those topics और उसको आप प्रिंट करके अपने पास रख लें ताकि ये आसानी रहे आपको. ये मैंने सारा, इफ यू सी दी, ये मटेरियल अवेलेबल है नेट के ऊपर भी, इसके मैंने क्रेडिट भी दिया हुआ है हियर, www.electronics-tutorials.ws. ठीक है, WS की वेबसाइट पे जाके आप वहाँ से भी आप दे सकते हैं अगर यहाँ से डाउनलोड ना हो तो. those tutorials are available that really helped me. The same topic I have been teaching, so that was available. That was easy part for me. For the electrodynamics, I have to write whole of the courses because of that, the non-availability of those solutions of the huge equations you have done in the previous. So I have to rewrite the whole all those lectures again, and then scan them, and then made the audio video lectures with the audio. So but anyway, so you can see this is very convenient for electronics people. You can get all of tons of knowledge, the tons of the information about the electronics. So let's I will go through quickly. I'm not going to teach you the gain here. So what we have, this is now basic oscillator. If you remember, I made actually here the block diagram over here. There was block, so it doesn't make any difference. This is the main amplifier. This is the feedback scheme, feedback circuit. I labeled that as the sampling network over here. This was the feedback network, and this was the mixing network, if you remember. And the same equations are applied here. Again, the solution, how to find the gain, that was the main here. They have not given the way which I have taught you in the class. That is the gain, voltage gain is given A, the gain of the amplifier, divided by 1 plus A, again the gain of amplifier, times the beta, which is the gain of the feedback amplifier. This is the feedback amplifier, this one. The beta is the attenuator, means the reducing the size. We take the small portion from the, this is a large output signal, we feed back, we rather give it to the, and it reduces the size of the attenuator, means it reduces the size, small portion from the output, and now here it is a feedback, plus or minus, which is the regenerative. In case of if it is a positive signal, they are in phase, in that means regenerative. If they are out of phase, then degenerative are, we can say that there is a then the negative feedback or the positive feedback. Regenerative means positive feedback, and negative means the out of phase, means the negative feedback. So that is the negative feedback part. Mixing network, this is the input, this is the mixing of these two, Vin, Vf. This is actually plus minus, so in both cases it normally happens. So this is the feedback network. Let's now move to the circuitry side. Oscillator resonance, we have discussed a lot. This is how the oscillator resonance is taking place. You again read out this whole topic, and you will find that resonance we have also discussed in the previous as well, AC circuits. So over there, the LC tank circuit, when we are, or either in series or in parallel, whenever XL is equal to XC, then resonance takes place. So XL is equal to XC. Here I think I have the XL is given by omega L, XC is equal to 1 over omega C. So some graphs are there, and this is again the same damping it we discussed over here, that how the damping is related with the RC time. RC is the relaxation time constant. T is equal to 1 over RC. So resistance inside the circuit and the capacitance, they make the RC the time constant over there. So here this discuss XL at resonance, XL is equal to XC. So resonant frequency is now given as here. This is the resonant frequency over here. So these are the graph for the XC and this for the XL. So what we have, the resonant frequency finally is equal to FR, or the F simply is equal to 1 over, this is FR is equal to 1 over 2 pi square root of the MC. So now this is now the circuit actually. We have the how we incorporate inside. We will do practical circuits in the coming topics, which is the Hartley oscillator and the Colpett oscillators. But here, what we have in the output at the collector, this LC tank circuit is connected. Now, in this case, we have the here you can see that this is the transformer linking the flux with the L with the secondary coil L2. Okay. Now this is actually this is the process through which we can reduce, or we can say, the small size, which is called the sampling network, which we would like to feed it back to the amplifier. So feedback is done through the transformer, the secondary coil L2, and is fed back to the amplifier. So basically it is connected in the collector output, the LC tank circuit, and small portion. Now we will see that the output may be taken from the secondary coil of the splitted transformer or the inductor, or we can have the splitted capacitor. That's what the Hartley and the Colpett two scientists did. Hartley did the splitting of the signal to feedback signal to the input through the inductor, and the Hartley did the splitting of the signal from the output to the input through the capacitor. But this is basically the feedback mechanism in the circuitry. So that is also the details are given in this topic. You go through and study those. So here is one of the examples. If the inductance of a 200 millihenry and a capacitor of 10 picofarad are connected together in parallel to create an LC tank circuit, calculate the frequency oscillation. This is just a 10th grade numerical, but you can see that how these problems we can find the resonant frequency if L is this much or C is this much, and other way around we can get this kind of questions as well. So the resonant frequency in this case is, if you put the values, 112.5 kilohertz. So that's the total summary of the at the end. Summary is also given, so you read that also, that summary. Okay, that was the second topic. I would like to, because there are 4 lectures, so I will like to go through all of those 4. Okay, 2 are done now. Okay, in this particular lecture, if you have any question, then I can take those questions. Let me know. जी, आप इसमें से कोई क्वेश्चन हो जो अभी मैंने टॉपिक किया तो आप पूछ सकते हैं. माइक ऑन करके बेशक आप डायरेक्टली पूछ सकते हैं. At the moment I have got 14 people. जी, anyone have any question in this topic, the second topic? I hope all of you are with me. जी, हाँ जी.
सर
Okay,
कोई
yes.
प्रॉब्लम नहीं
जी
है.
जी.
थैंक यू सर.
जी बोले प्लीज.
सर कोई प्रॉब्लम नहीं है. थैंक यू सर.
अच्छा, प्रॉब्लम नहीं है. गुड. चले, ठीक है. एटलीस्ट जो भी एक स्टूडेंट भी अगर बोलता है, कोई प्रॉब्लम होती है, तो वो इट्स गुड दैट द रेस्ट ऑफ द स्टूडेंट्स कैन एटलीस्ट फॉलो दोज. अगर एक भी डिस्कशन में हो जाए तो ओके, दैट्स गुड. चले, आई विल नाउ मूव ऑन टू द अदर वन. I have shared all the entire screen so that I can quickly move around in my laptop. S1 is done now. S2. In the next, S3 is the next. I think the third week assignment I will give you. But let's go to S2, S2A. Let me this turn off these documents. No, I don't want to change. Okay, let me S2. This is the Hartley oscillator, and then S2B, and this is the Colpitt's oscillator. They are short, small topics, not that much big, but still. Okay. This was assignment this week. I suppose that मुझे अब याद नहीं exactly, but anyway, I think मेरा ख्याल में इसी हफ्ते की दो assignments हैं. The Hartley oscillator. This is now the continuation of the previous topics. The oscillator section, which we have basic working mechanism and the electronic circuitry we discussed. Now in detail, actually practical oscillator, how the circuitry works, that is being described over there. So Hartley is the name of the scientist who developed this technique of the oscillator circuit. So the Hartley oscillator design uses what the basic feature of this oscillator is that it uses two inductive coils in series with a parallel capacitor to form its resonance tank circuit, producing sinusoidal oscillation. One thing more, I forgot to mention that oscillators are of basically two types. One is the sinusoidal oscillators and the other is the non-sinusoidal oscillators. Okay, so these we are discussing the sinusoidal oscillators, which are the sine wave or cosine wave or any the sine wave based on the sinusoidal oscillations. The sinusoidal, like the square, the spikes, the triangular wave, the other kind of the oscillatory signals we would like to have, wave shapes we would like to have. Those are made from the special devices we will discuss at the end. That is the unijunction transistor or the other special devices, or the SCRs or the silicon control rectifier. They are used special. We are also called bistable or astable multivibrators as well. So those are the non-sinusoidal oscillators. But here we are discussing the only sinusoidal oscillators. So sinusoidal oscillator means the tank LC tune or tank oscillators. One thing I would like to mention more, that in tanks oscillations there is a limit. You can increase they have the oscillating frequency, resonant frequency, let's say up to 1 gigahertz. Okay, there is a reason behind it, because the resonant frequency, you know that it is given by f resonant frequency is given by 1 over 2 pi under root LC. LNC, it depends upon LNC. So it has a limit 999 megahertz, or about 1,000 megahertz, which is 1 gigahertz. Beyond that, it won't work. For the high frequency signals, there are separate other like the Clairon tube. Various tubes are used where the electron oscillates over there, energy oscillations that is used electronic over there. So this tank circuit won't work. Reason why it won't work? Very simple. I could ask from you, but anyway, since this is a start for you, so I'm not going to put you this question. The reason is that since the resonant frequency is depending upon two things, L and C. Okay, we can reduce the C as much as we can by having the dimensions C, the distance between two up to micron level. We can it's more smaller the distance, means the how it will higher the area, higher the capacitance. Smaller the distance, the larger the capacitance. It's inversely proportional to D. So you can increase the distance, you can decrease the capacitance. By decreasing capacitance means you can increase the resonant frequency. Similarly, by decreasing the inductance, you can increase the resonant frequency. Okay, we can reduce as much as we can pico, femto, tends to, let's say, minus 18 or minus 16 or minus whatever 12. What happened that when we reduce the L at a very small capacitance, tends to, let's say, minus uh, 15, okay, picofarad, the two coils of this inductor, the small D2 coil, they behave like a two capacitors because they are two. The wires are separated with a small distance. Coil are just with the insulating material, the coils wires. So they act like a tiny capacitors. So its capacitance, fixed capacitance is there, which is for limit is that 1 gigahertz. Beyond that, it won't work. That appeared that the wire as a loop they are placed inside the coil. They behave like the small tiny capacitors, and its capacitance is then added to the this. So no matter how much you decrease the capacitance of this, but due to this fixed capacitance of the coil, that limits the resonant frequency at the output. So that's why it is not the used for the higher frequencies. Okay, so the let me go quickly go to read out all these. So this is the what happened. The this is the normal LC tank circuit. So we have the what Hartley did. Hartley did it splitted, it divided this capacitor, this inductor into two parts, splitted coil L1 and L2. So it seems almost the similar, the same center tape, but actually this one part is a smaller one, which is used to feed back small portion of the signal, which is being obtained at the output and fed it back to the input. So that is the main key feature of the Hartley oscillator. Okay, so here's the typical Hartley oscillator. Okay, so it seems that it is being connected at the base, right? But actually what we have, this is connected, right, if you see here, to the collector here. So I have told you in the class that when the wire is crossing over another wire, it is not connected. The wire, the connected points are the node where the dots are there. Okay, these are the dots. So this is a typical amplifier. It's a common emitter self-bias amplifier. You can remember we have discussed. This is a simple amplifier, common emitter amplifier, which is can be identified with the four typical resistors: R1, R2, which is a potential divider, and R3 is the collector resistance, R4 is the emitter resistance, C is the bypass capacitor. These things I have discussed in my video lectures. Okay, I'm just warm up, giving you the basics. So you go through those videos, everything is being explained over there as well. So bypass capacitor means that the here any output signal, if it is being dropped here, causing the reduction in the gain, can be bypassed. So it is, capacitor is a good conductor for the AC and bad conductor for the DC. So DC will not go through, but the AC will go through and join at the output. Okay, so what we have, remember this LC tank is connected at the collector. The output is given to the base. It feedback into the base. Base is the input terminal for the amplifier. So that is the L1, and L2 is typically a smaller one. Okay, is a very small coil. Let's say if there are, let's say 2000 or 1000, suppose 1000 turns, so you may have 10 or 15 turns at the most. So you can have small voltage which is now fed back. Here you can see the arrow, it is being fed back from the L2 right to the base. Since this is AC signal, so its capacitor will allow the AC. This DC is released from here. Okay, the DC is released to the charge the capacitor. The capacitor is made variable in order to have the variable frequency, but we can have the fixed capacitance as well. So the The DC VCC charge this capacitor, charging and discharging, that whole mechanism process takes place. Like we discussed before, oscillations are produced and they are being fed into this is the oscillation produced at the output, but a small portion is fed to the input so that we could have sustained these regular oscillations, no damping at the output. So in the topic, if it comes in the exam or if you are asked, so you have to explain the mechanism of the LC tank as well as the function of all these components inside this amplifier. What is the job of this capacitor? To block DC and allow AC to the output. VCC is here, which is used for the DC biasing. DC biasing of amplifier, which maintains it at the class A load line Q point at the middle of the point, which is class A amplifier is used as a amplification, and the Q point is located right at the middle of the load line. So that is the collector job is to provide the Q point current, ICQ, okay, current which is maintained at the middle of the load line. And similarly, the job of these R1 and R2 is they provide base current, Q point base current, IBQ, to the base. And this is emitter. Emitter is used to stabilize the Q point at the load line. If you remove this, then instability in the load line takes place. The slope of the load line is increased. With the introduction of this at the emitter, at the output you can see the collector resistance. You have got the collector to emitter junction resistance, and this resistance further if you add, then what we have, the increase in the resistance at the output causes the decrease in the slope of the load line, which brings the stability in the Q point. So that's how the Hartley oscillator works, right? It is splitted output signal, the small signal is fed into the input. So rest you can see study. That is how we get the total inductance is the sum of these two, L1 plus L2 plus mutual inductance. M is for the mutual inductance. Here it is written. Okay, so shunt fed, I think that's it. Shunt fed means there is series feedback and shunt feedback. So shunt fed, this is also another circuit, but no need this for this circuit. You just go that only one circuit, the series feedback, which is the previous one, that will be used in your topic. So examples are again given here. This is the numerical example. Values are given, that if these are the values, then find the the frequencies, various FH and FR, high pass and low pass, two frequencies. You can go through that. So that is the way self-explanatory, no need to have the it is explaining in this problem that if we have these inductances, a Hartley oscillator having two individual inductors of 0.5 millihenry, each are designed to resonate in parallel with variable capacitor that can be adjusted. Now this is the range of the capacitor, which can vary from 100 picofarad to 500 picofarad. So one by one, you just first go to the 100 picofarad, and then you go to the 500 picofarad values you put, but obviously 0.5 millihenry each means the inductors, two inductors we have 0.5 millihenry, 0.5 millihenry, two each. When we add them, 1 millihenry you get. And first you put the 100 picofarad, then FH frequency you get 1 point, which called the upper frequency, and then lower frequency, higher frequency and lower frequency. Why we are using lower and higher? Because this one higher because the value C is smaller. Smaller C means the higher frequency, and this is the C is larger over there, means the larger the value, smaller will be the frequency. So lower frequency you will get. So these two frequency ranges will lower frequency and the higher frequency. You can get the bandwidth from is the difference of these two higher, the difference between the higher and lower frequencies, which is 278 kilohertz in this case. So this is also not required Hartley oscillator using an op amp. This is the just a supplementary for those who want to study further addition add-on. So this is the Hartley oscillator. The if you have any question in this topic, then you can discuss with me. हाँ जी, किसी को क्वेश्चन इसमें हो तो पूछ सकते हैं. मैं आगे मूव करता हूँ कि दूसरे कॉर्पोरेट ऑसिलेटर की तरफ. टाइम तो हो चुका है, लेकिन नेवर माइंड, वी कैन कैरी ऑन. एज आई टोल्ड यू, वी कैन minimum time is 1 hour. We can go ahead, no problem, 2 hours, 3 hours, as long as we finish the topics. Okay जी, anybody, any question? जी कौन है? Let me see. Is that clear? The topic is clear? कोई एक भी बोल दे कि yes or no.
जी सर, क्लियर है सर.
ओके ओके ओके, थैंक यू थैंक यू. मुझे पता लगे कि माइक म्यूट है. मैंने कहा ये नज़र तो आ रहा है मेरे पास 12 people have joined, लेकिन ये कि I suppose that everyone has got the audio video is working. That is audio आप सुन रहे हैं very clearly. तो सर कमेंट में लिख दिए करें, yes कर दें कि you are getting my audio signal loud and clear. Okay, now let's move to the second. This is a culprit. These are the two scientists, your favorite scientists, who developed all this circuitry for you to educate you. And the physics people normally don't like these scientists, and electronics especially. They say what the kind of the things, the stuff we are studying, they are normally pretty uncomfortable. Okay, but anyway, that is the reality, that electronics is an integral part of our now social life, and especially as a scientist, you have to understand the language of this electronics, how the components and how these things work. Okay, the culprit oscillator, very key feature is very simple. The differentiate from the Hartley is that in the Hartley we were having one capacitor and two inductors splitted. In this case, one inductor and two splitted capacitors. Okay, so that's the only difference. The culprit oscillator design uses center tape capacitors in series with a parallel inductor to form its resonance circuit, producing a sinusoidal oscillation. This is the basic core simple but the definition of the culprit oscillator. Okay, so I will go to directly this. I have done these simple calculations. So these documents are available on the net. In the video I have discussed in detail. Download that video or through the YouTube, or watch that video on the YouTube. You get all the details. So I will just quickly go through. I've just mentioned over how you give capacitor reactance. You calculate from here. Okay, so okay, here is the typical basic culprit oscillator. So you can see in this time they have used the L2 inductor in the collector. So you can use in the Hartley as well. This we will call that not L2 but some L or L0, because L1 L2 over there in Hartley. So no problem with that. This is the typical procedure that we can use to L2 in order to block any the AC signal going into the collector. Noise वगैरह हम इसको block करना चाहते हैं. AC signal इसमें नहीं जा सकेगा, because inductor blocks AC and allow DC. The DC when released is completely, this is called RFC. RFC means radio frequency coil. R for radio, F for frequency, C for coil. So RFC coil radio frequency, जो radio frequency के wavelength में आता है. So क्यों RFC करते हैं कि हमारे उसमें स्पेस में रेडियो सिग्नल्स हैं बहुत सारे, ठीक है. FM चल रहा है, दूसरे चल रहे हैं, या शॉर्ट वेव, लॉन्ग वेव. तो वो जो है दे माइट बी पिक्ड अप इनसाइड any component, so they can produce noise. So in order to do that, to block that, there are other advanced circuitry available, but L2 is a, as a precautionary measure, is connected in the, it has a pretty high resistance as well, which controls the collector current as well. So this is a transistor again, NPN, and it's a self-bias common emitter amplifier, and also that was, the previous one was also common emitter amplifier. So we have the same at the collector. It is connected. Remember, this is the collector. Okay, the wire is coming here. If I take this whole of the circuit and take it to the front, I can take right away. This wire is not joined. Okay, okay. This is the feedback wire which is coming back. You can describe it in another way as well. But in this slide, they have used in the C this circuitry at the back. So, but remember, this is connected at the output. This is because here the connection of the wire is at the collector. So this is now, this time we have the LC tank oscillations. The same way, the here the voltage is released to the tank and oscillations are produced. Feedback is done through, is a series feedback again. There's shunt feedback and series feedback. There's a series feedback. We have done those in the feedback schemes. And what is the series feedback, and the voltage series and the current series feedback, current and the voltage shunt and the shunt voltage and the shunt the series shunt current feedback both. So in this case, it is the series feedback because it is connected in series right into the base of this transistor amplifier. This is a amplifier. Again, this is self-bias amplifier. Here the we don't have the emitter resistance. You can put that in your circuit as well. So, and bypass resistance as well. So that is the small portion is taken from the C2 this time and fed to the input, and this oscillator signal are transmitted through the C3 to the base, and those oscillations are then amplified at the output. So at the output, which we have got the oscillatory signal here. So Colpit, only difference is that the Colpit oscillator uses test the same functions you have to explain in the paper or in the report. If it is online, then if it is asked, that the various questions will be asked, so you can explain these, what are the functions of these various, or you, it can be asked what is the function of R1, R2, C3, C1, C2. So you better now study the topics from that point of view, that no component, anything you write, that should be explained by you. Okay, so that is the culprit. Now coming to, now this is the, since the capacitor are connected in series, and you know in series capacitance we have the opposite to the series resistor is 1 over CT is 1 over C1 plus 1 over C2. So CT is C1 into C2 divided by C1 plus C2 is the equivalent or the total capacitance of the whole of the coil. You can give it the value over here. So that is also given. Feedback fraction is C1 by C2, that whatever the total capacitance C1 divided by C2, that is there. This is the example is given. A Colpit oscillator circuit having two capacitors 24 nanofarad and 240 nanofarad respectively are connected in parallel with an inductor of 10 Henry. Determine the frequency of oscillation of the circuit. Now the oscillation frequency of the Colpit is given by f of r is equal to 1 over 2 pi LCT now. So the Colpit circuit consists of the two capacitors in series, so equivalent capacitance is obtained, which is 21. In this case is by putting the value of each C1, C2, we get 21.8 nanofarad. So if you put that value here, you will get the resonant frequency 10.8 kilohertz, 10.8 kilohertz. So frequency of oscillation for the Colpit is therefore 10.8 kilohertz with a feedback fraction. So if you put the values away, feedback fraction, which is a 10%. So you can see very small portion of the signal is being fed back, the 10% of the total. Okay, these are further other designs you can have. Okay, so that's the end of this topic as well. So we have discussed all the four topics in the previous the 2 weeks. The third week you will be getting in the next tomorrow, inshallah, in your emails, through the Google invitations. Okay. So any question now? If any one of you have any questions, then you can join. जी किसी को कोई क्वेश्चन हो तो इन टॉपिक्स पे, चार टॉपिक्स हमने किए हैं अभी, we can discuss. Okay, any other problem, any other question regarding this online teaching methodology या कोई issues आपको आ रहे हो, you can discuss. You can open your mic, anyone who want to talk.
Sir,
जी वाह.
sir, the inductor symbol की यो side बांधे dot भी. Sir, the dot से मतलब थे.
यो मिनट कम यो देखिए डालता.
The upper dots चिकन दी sir.
This one is with core. The core is inside. अब लाइन होना ना चाहिए ना.
जी sir.
Core दा पारे. जी. It is not empty, I think. मेरे ख्याल में it should be
Sir,
dot should be
बने
for
दी
the
sir
core.
दे purpose दा पारा दे.
Ah wow. This is with
जी,
core.
sir.
It's not empty. With core.
Okay sir.
I will confirm that again, but I think this is a new symbol, something that I have taken this from this website. They have used some, there are some mistakes as well, but I suppose that this is a for the core, क्योंकि coil के अंदर है, I suppose that. Oh,
जी sir.
या इस ये भी starting point भी नहीं हो सकता कि we can't say that. I will check that out again, but I suppose that this is with core.
जी sir.
ठीक है, ये हो सकता है. So it's good that considerable number. Still, I think 34 strength थी हमारी, and today joined at the most around अभी 9 रह गए. But anyway, about 14 maximum I got the attendance. Attendance आपकी मैं साथ साथ सेव करता जा रहा हूँ. ठीक. In attendance जी वालेकुम सलाम जी.
wants to join in तो लेकिन वो कह रही है कि मीटिंग में join in नहीं कर पा रही क्योंकि आगे से notification आ रहा है that when somebody let you get in then you will join.
I have if I get the request. Normally if you are out of domain, अगर आप किसी और से कॉपी होके मैंने जो भेजे और जो मेरी इनविटेशंस गए होंगे तो आप ज्वाइन कर सकते हैं. ठीक है ना. लेकिन अगर आपने किसी का लिंक कॉपी करके किया तो फिर उसमें आपको परमिशन की जरूरत पड़ेगी. ठीक है ना. अगर किसी फ्रेंड से लिया है, नो प्रॉब्लम विद दैट. अभी आपने ज्वाइन किया है
सर मैं नहीं सर किरण वो उसका मुझे टेक्स्ट है वो ज्वाइन कर रही है बट उसको वो परमिशन नहीं मिल रही मतलब वो कर नहीं पा रही.
क्या
तो वो
कौन नहीं कर पा रही.
नाज सर उसने वो कहा है कि आस्किंग टू
किरण
ज्वाइन.
नास. ओके दोबारा ओके ऑलमोस्ट सेशन इज ओवर. आई विल सेंड इसका अभी जितना भी हमारी आज की हुई है मीटिंग उसकी जितने भी डिस्कशन हुई है उसके वीडियो का लिंक उसको मिल जाएगा. ठीक है ना. तो नेक्स्ट इंशाल्लाह टाइम उसको वो ज्वाइन करे नेक्स्ट वीक.
इन दिस मीटिंग बिफोर अभी वो पूरा उसने लेक्चर अटेंड किया बस वो भी एंड में थोड़ा
अच्छा
डिस्कस की तब वो
अच्छा मे बी मैं इधर बिजी था इसमें डिस्क्राइबिंग टॉपिक डिस्कशन में, तो उस वजह से मेरे ख्याल में उसको अलाउ नहीं कर सका. सो एक्चुअली अगर आप हमारे अपने डोमेन पे होते तो वो फिर प्रॉब्लम नहीं ना होती क्योंकि हमारा यूओपी का डोमेन है गूगल में और आपका चूंकि जीमेल से वो आउटसाइड डोमेन कंसिडर करते हैं. बट एनीवे उसको ये मिल जाएंगे आप सबको, ये इसकी कॉपी मिल जाएगी वीडियो की भी. राइट. Okay, so different, let me take attendance साथ इसे हम करते जा रहे हैं ताकि all right, let me save this. All right then, I think if you have further any question, still I can wait for you, no problem with that. So you can discuss. If you have any question, कोई question नहीं, I suppose. Okay, then we end our session over here. Inshallah, we'll meet again next week, the same time, same day on Saturday, 11 a.m. And again, I request you try to convince your class fellows that come and join the class. Although I have uploaded all the literature material, but it is good for you, for your sake, that face to face the discussion on the topics that could help the other students as well. That could be done. So help your friends in joining the class. उनको communicate करें जिनका Facebook पे ID नहीं है, email वगैरह वो नहीं देखते, वो जने कसांडे बादशाह नहीं बिल्कुल डगोरी ना. फाइनल आपका ये अपना क्या है, सज्जाद गनी, ही कॉल्ड मी yesterday when I was driving. सर जी हमें तपोस स्कूल उचित है, ऑनलाइन क्लासेस में कल स्टार्ट की, मैं तो आती हुआ क्यों दे. मैंने उसको इसी तरह कहा, मैंने कि हाउ कम यू, I contacted you so many times, your mobile phone was completely off. मैं तो उस रहा उधर तक सुना कि we were so in a trouble that in communicating, so that we get communication with the students. So I told him that he should be showing the responsibility, the responsible behavior. तो अब वो आ गया, मैंने कि contact उज़ैर साहब is under tremendous pressure. He has so many groups, more than 8 to 10 groups. He is just communicating with the students and getting the email address. So many times I get, still some of the emails are still wrong, but I'm trying to get the email addresses. So you should get also the correct email addresses of your friends. If you think that your friends have not joined, then send me their email addresses on my email, so that I can invite them as well. So you will get regular invitations of the Google Meet to your email box. Check your email box, and I will also be sharing on the Facebook. But main medium of communication will be email. So check your emails regularly. Okay, then I will stop this meeting over here, and see you next time, inshallah. Allah Hafiz.